Reading from Earth in Space, page 54. The reasons for seasons. Like all the planets in our solar system, Earth orbits around the Sun. Earth also rotates on its axis, which is currently tilted 23.5 degrees to the plane of its orbit. While the tilt of Earth's axis will change very little over your lifetime, the part of Earth that is exposed to the most solar energy from the Sun, does change, and on a regular basis. This is because the tilted Earth orbits the Sun. What do you think causes the seasons? Many people believe that seasons depend on the distance between Earth and the Sun. That might seem logical, but consider this. Earth travels in an ellipse or oval around the Sun. Due to this ellipse, Earth is slightly closer to the Sun in December than in June. If the distance from the Sun were responsible for how warm Earth is, it would mean that everyone on Earth would have summer in December. You know this is not true if you live in the Northern Hemisphere. It is Earth's atmosphere and the tilt of its axis that are responsible for the changes in seasons. These factors affect the amount of solar energy that reaches each part of Earth at any time. The tilt of Earth on its axis affects the angle at which the Sun's rays pass through the atmosphere and strike Earth's surface. The higher the Sun's angle, the more intense the solar radiation, and the less atmosphere the rays must pass through. The lower the Sun's angle, the less intense the solar radiation, and the more atmosphere the rays must pass through. See the illustrations. The tilt of Earth also affects the length of daylight in any particular area. Between March 21st and September 21, on average, the Northern Hemisphere tilts toward the Sun. During this period, the surface of Earth in the Northern Hemisphere receives longer periods of daylight than the surface of Earth in the Southern Hemisphere. More direct sunlight for longer periods causes warmer weather. However, between September 21st and March 21st, the Southern Hemisphere tilts toward the Sun and has warmer weather. On December 21st or December 22nd, depending on the year, the Southern Hemisphere celebrates the first day of summer, called the summer's solstice. On that same day, the Northern Hemisphere experiences its first day of winter, the winter solstice. On 2 days of the year, somewhere around March 21st and September 21st, the Sun is over Earth's equator and neither hemisphere tilts toward the Sun. On those 2 days, the surface of Earth and both hemispheres receive equal amounts of energy from the Sun. Night and day are almost equal in length all over the world except at the poles. These 2 days are called the equinox. To remember this term, think of equal night. Equinox occur midway between the solstices. On average, December 21st has the shortest period of daylight in the Northern Hemisphere. But December 21st is not usually the coldest day of the year because it takes several weeks in fall and early winter before the atmosphere and oceans cool off. There is a lag or delay in seasonal temperatures, and the coldest period in the Northern Hemisphere therefore may not arrive until early February. The same seasonal temperature delay occurs in spring and summer. The amount of solar energy that reaches each hemisphere affects the temperature of the Earth's surface. Even though the Sun is closer to Earth in winter than in summer in the Northern Hemisphere, the Sun's rays do not hit Earth directly. The rays hit it at an angle after passing through the atmosphere. During winter, there are also fewer hours of daylight, which accounts for some of the chill of winter. Did you know that other planets also have different seasons? The spin axis of Uranus, for example, points to the Sun. That means that Uranus is tilted about 98 degrees to the plane of the ecliptic. the plane along which the Sun exists, compared to Earth's current tilt of 23.5 degrees. With Uranus completely on its side, one hemisphere always has summer during half of Uranus's 84-year orbit around the Sun, while the other hemisphere doesn't experience summer until the second half of its 84-year orbit. This pattern creates 42-year seasons of warmth and cold on each end of Uranus. Other planets also have interesting relationships to the Sun that cause different seasonal characteristics. We will learn more about them in part 2 of this model. End of the reading.